Hello and welcome. Some time ago I started a row of videos about my first personal 8-bit computer experience. I got a VIC-20 and a C64 in bad condition to work with. In the last video I restored the VIC-20 and in this video I'd like to show how I struggled to get the C64 usable again. I'd like to remind you that this was my first and single C64 in my life, so repairing it was an interesting adventure for me. I couldn't just exchange parts with another C64 to test them and had to figure out what was wrong by myself. Honestly, I made all this quite some time ago, but due to seemingly low interest, I didn't make this final cut. Anyway, I wanted to finish this, and here you are. This C64 was already visually in a pretty bad shape. The Commodore sticker came off, there were some stickers on the case, something was tinkling inside, and the whole case itself was very dirty. You barely can see it through the camera, but the whole computer was covered with a kind of oily film, sticky and disgusting. There were 2 holes drilled on the left side, and the whole thing also had slight smell of cigarettes and needed a good wash. The first test offered just a black screen, so obviously the computer was also broken and required a careful look into electronics. I started to disassemble it, and right after opening the case, I could see the reason for tinkling inside. There was a custom modification. Somebody added a reset button, which probably should go into the holes in the case. However, it was not fixed and was just flying inside of it. Oh, and the keyboard was just disgusting. Look at that. The keyboard PCB itself looks clean. It is very sensitive and carbon-covered contacts can be damaged easily, so I just cleaned it with a piece of cloth. The keyboard stamps are also very sensitive, so I didn't touch them, but almost everything else went into a soapy bath. Oh, just look at the color of the water, where I had left the keycaps for half an hour. I scrubbed the other parts with a brush and a breath cleaner for fat and oil. It removed a lot of brown gunk from the housing, but you should be careful with it since it is quite aggressive. Don't leave it working for more than a couple of minutes or it will damage the surface. I washed the steel springs using WD-40, they were already a bit rusty. Putting the keyboard back together went without an issue, and with a little help of my wife, all the keycaps were put together in a couple of minutes. Now to the electronics. There were some residues from the previous modifications on the board. At least RF modulator and the SID were previously touched. The SID chip had also kind of sticker leftovers on its top. First, I started to test the voltages. The regulators for 12 and 5 volts seemed to be okay. The VIC chip which is responsible for video output, got its 5 volt properly. However, beside 5 volts on pin 40, the used 6567 chip also should get 12 volts on the pin 13, which it also did. I continue to measure voltages and they all seem to be alright. The 6581 SID should get 12 volt on pin 28 and it did. However, I realized that the chip got quite hot, so I decided to remove it so far, since it's not necessary for essential functionality. All the other voltages seem to be okay. It's often possible to find broken ICs by just touching them. If they are too cold or too hot, it could be a hint that the particular IC is defective. After a while, I realized that the PLA is a lot hotter than everything else on the board, and black screen is often a result of broken PLA. Unfortunately, it was soldered, so it was time to turn on my soldering iron. First, I removed the flying reset button. I wanted to restore this C64 to the original state as far as possible anyway. Then I cleaned the old residues using some IPA. With some fresh solder and my desoldering gun, removing the PLA was child's play. After some cleaning, I added new socket for it. I know this is not the best one, but this is the one I had at hand. An original replacement for the PLA is not easy to find today. They are not produced anymore. The old stock is quite expensive and due to bad manufacturing process, the chips break even if they are not in use. Instead, I ordered a FPGA-based Plankton. As far as I was told, this gives the best compatibility and it stays absolutely cool and therefore more reliable. I got my package from UK and beside the information paper, which you really should read carefully, the desired piece of technology was included. Dropped into the fresh socket, I connected the video output and the power supply to test the board. However, after turning on the computer, the behavior didn't change much. Black screen as it was before. Well, that still didn't mean that the original PLA was not defective. It was, as I found later, so ordering Plankton was still the way to go, and I had to continue the search. To be able to check the traces and parts properly, I desoldered some ICs and put them into sockets. Among others, the CPU and the CIA chips. I also removed some strange diodes from the resistors near the CIA chips. They looked badly, custom made for me, and I don't know why they were there at all. Probably to work around some issues? Please write in the comments should you know more about it. I didn't film everything, but I made a lot of investigation. On the board as well as in the internet. I used this logic probe a lot and it helped me to understand the signaling better. After the dead PLA, a defective memory or chips in this area seem to be the most common issue, so I concentrated on it and resocketed some chips in this area. In particular, these MOS 7708 multiplexers, which are located here and responsible for the memory chip selection. These chips are identical to widely available today 74LS257 ICs. Luckily, my flash programmer TL866 can also validate some logic and memory ICs. And as you see, my suspicion was confirmed. One of the two ICs was defective. I also checked the hex inverter, which was fully working. So, I could just buy the 74LS257 and move on, but I found something better. This K555 KP11 were made in the Soviet Union and a drop-in replacement for Western 74LS257 ICs. I found it kind of funny to have some Soviet parts running in a Western computer, both made in the time of the Cold War. Let's call it one friendly union, and this C64 officially became a CCC64. After putting back the PLA and all the other ICs, it was again time for testing. And this time the computer got finally back to life. It was a huge relief after a lot of blind poking around and searching for the issues. Okay, where the electronics was back to life, I had to take care of the housing. After washing, it turned out to be quite nice. There was almost no yellowing, so no retro brighting was necessary. However, same as with the VIC-20, this one had broken standoffs in the back. This seemed to be a very common problem. Luckily, I already found a solution for VIC-20, which I could apply here as well, so I 3D printed the standoffs in the same way and glued them in place. Putting everything back together was not an issue. Everything went just fine and the new standoffs worked perfectly. I cleaned the Commodore 64 logo with some alcohol and applied double-sided tape to stick it back to the case. And this is actually it. Looks way better. It's clean, working, and ready to dive into some 8-bit computing. The housing still has some scars of time, like these 2 holes on the left side, but hey, this has a story to tell. Off camera, I tested once again the old PLA and it was dead indeed, so buying Plankton was just right. As I told before, I have had no experience with C64, so I already bought some books and peripherals to be able to load some games and programs and just to see what it feels like to be a C64 kid in the 80s. So far, I hope you enjoyed it as much as I did. Please leave your comments, likes or dislikes below, and I say goodbye for now and hope to have you on my channel again.